If you've encountered a high-quality, modern cannabis cultivar, you already know the scent. It's that sharp, high-octane gas aroma that carries across the room. For decades, the industry relied on a straightforward scientific explanation for every scent the plant produced, a class of aromatic compounds called terpenes. This chart outlines traditional laboratory testing. Laboratories map out high percentage levels of common terpenes, pointing to molecules like myrcene for sweetness or caryophyllene for spice, to define a standard aroma profile. The belief was absolute. If you decoded the terpene data, you could predict the final scent of the flower. But when laboratories ran the numbers on the most pungent, diesel-scented strains available, the data didn't line up. The terpene profiles were often unremarkable, failing to explain the heavy fuel scent. This highlights a significant blind spot in traditional testing. There is a missing data block that terpene analysis simply cannot see. Attempting to measure that distinct pungency by counting terpenes is like trying to measure the brightness of the sun by counting the stars. For years, the focus remained on the wrong set of chemicals to explain these high-octane genetics. The actual source of the gas profile is a hidden class of molecules known as volatile sulfur compounds, or VSCs. Specifically, they are an order called prenolated thiols. As the name implies, these compounds are built on a chemical foundation of sulfur, the same element nature uses for high-intensity defensive aromas. It is the same foundation that gives a skunk spray its intensity, or a clove of raw garlic its sharp bite. Here in this molecular model, we see the botanical engineering at work. The plant binds a sulfur atom to a specific prenol group, creating a dense structure that emits immediate aromatic shockwaves. This specific molecular combination produces a piercingly loud aroma that exists far outside the standard terpene scale. The difference in scale is massive. Laboratories measure terpenes in whole percentages, meaning they make up a physically significant portion of the plant's essential oils. By comparison, the prenolated thiols exist in nearly undetectable, microscopic fractions. In terms of physical volume, they are almost invisible next to the terpenes. But the human olfactory system is biologically hardwired to detect these specific sulfur molecules over almost everything else. Our sensitivity is so high that we can detect these compounds at mere parts per trillion. Because of that biological tuning, a single trace of a sulfur compound effectively dominates the entire profile, even when hundreds of terpenes are present. Pinpointing the role of these prenolated thiols is providing commercial cultivators with a specific chemical target for their breeding programs. Breeders no longer have to guess at final aromas based on outdated terpene reports or trial and error. Instead, they are using data-driven analysis to isolate and trigger the specific biological pathways that produce these trace sulfur compounds. By intentionally selecting for these hidden molecules, breeders are producing levels of pungency that weren't possible through terpene-focused selection alone. For the consumer, this era of precision chemistry means access to cultivars with unprecedentedly loud profiles and high potency. This increased access requires a commitment to safe and responsible consumption. It is essential to always follow the laws and regulations within your local jurisdiction. These botanical findings are purely scientific and do not constitute medical advice. For physical ailments, always consult a licensed physician. Science has provided the data to explain the source of the gas profile, but the most important part of the experience remains safety and respect for your own health.
What was I saying?